dari kelompok 1 ingin mensurvei lokasi geotekstil kami. Geotekstil Lereng. Kami ingin mensurvei lokasi lereng kami yang ada di lokasi Labuhan, Sungai Deli. Ya, kalian bisa lihat perjalanannya. Check this out. Terus saja. Nanti nabrak nggak salah. Ini adalah tanah lereng yang ada di Sungai Deli. Apa? Pabrik. Bisa kan? Carilah orang. Sampai dekat rumahku. Untuk melihat sekitarannya. Turunin nih. Dan ada sini. Apa sih? Inilah lereng. Lereng kalau kamu terjun 2 pukulannya mati. Patah. Inilah dia. Coba aku terjun dulu. Enggak rupanya. Nah, jadi gimana Bang tentang lereng ini Bang?
Jadi Assalamualaikum warahmatullahi wabarakatuh. Jadi kami sudah ke tempat di daerah yang kami ini ada tersebut dapat sebuah lereng. Jadi stabilitas lereng itu adalah tanah miring atau yang disebut lereng batu yang menahan pergerakan. Jadi teman-teman, kami menggunakan satu software, yaitu untuk mengukur lereng tersebut. Jadi teman-teman, dikarenakan air naik, makanya tidak terlalu jelas lereng tersebut. Kalau air sudah surut, lereng ini bakal dalam, sangat dalam. Jadi bukan karena kami waktunya tidak, memang waktu yang tidak memungkinkan karena selama 2 hari ini terjadinya penurunan hujan di daerah tersebut, daerah yang kami tuju. Jadi teman-teman, inilah lereng yang kami. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Hello, hi, good morning. So I'm Muhammad Yusuf. So today I would like to share how to model and how to analyze the slope, the soil slope, okay, using Plexis 2D. Okay, so I will show you in Plexis 2D 2015. So I will show you the simple model. Okay, so this is the model. Okay, the slope model. So in this slope model, we have two layers of soil. Okay, so we have upper layer soil and the lower layer soil, and the height of the soil is 15 meters. And actually, this is the parameters. Okay, the required parameters. If we choose the more column model, so if we choose the more column model, so this is the important parameters. So we have to know the Poisson ratio. Okay, we have to know the Young modulus, the cohesion, the friction angle, the dilation angle. Okay, so this is the parameters for layer 1, for the upper layer, and then this is the parameters, okay, for the lower layer. So, and the gradient is 45 degree, 45 degree, and the length of the slope is 40 meter. Okay, the length of the slope is 40 meter, and we want to model, to sketch, and then to analyze in the Plexis 2D, right? So how actually? Okay, so before we sketch the geometry of the soil slope, so we have to know the coordinate. So if you see here, so this is the coordinate. Okay, start from 0, 0, 40, 0, 44, 34, 29, 0, 9, 0, 14, 10, 14. Right, so this is the coordinate. So you have to know the coordinate, and then okay, sometimes you have to draw the groundwater table. Okay, you have to draw the groundwater table. So this is the example. Okay, and then this is the coordinate of the groundwater table. Okay, okay, so you have to sketch using this coordinate. Okay, start from 0, 10 here, 16, 8 here, okay, then 24, 7 here, and 47 here. Okay, so this is the model. Okay, this is the slope model. So we are going to sketch in the Plexis 2D, right? Okay, so we open Plexis 2D. Alright, so this is the interface of the Plexis 2D. So you can name the title here, okay, as slope stability, for example. And okay, the model. Okay, the model. Okay, so for the slope stability, we use the plate strain. Okay, we use the plate strain and 15 noded, and you can use this default unit. And then the important part here is, okay, the contour. Okay, because your model is 40 meter length, so if you refer to this 40 meter length, okay, so you have to set up, and the height is 14 meters. So in Plexis 2D, so you have to set up X max to 40 because the length of our model is 40 meter. And then Y minimum is 0, it's okay. And then Y max is the total height of the slope is 14 meter. Okay, and then you just click OK. Now, okay, we start to sketch the model. Okay, so before you sketch the model, you have to know the coordinate, right? So this is the coordinate, and you have to sketch for each segment. So this is, we have two segments here, 1, 2, right? So okay, to sketch the slope model, okay, you go to the structure. Okay, you go to the structure. Then, okay, before you start sketch, okay, so make sure you save first. Okay, you save, and then okay, slope stability in desktop. Okay, slope stability desktop, save. Okay, replace. No. Okay, we name it as slope stability tutorial. Okay. Okay, and then save as file. Okay, and then we sketch the model. So you have to know the coordinate. Okay, so you select the create soil polygon. Okay, create soil polygon. So you start from here, from 0, 0. Okay, from 0 to 40, 0. Okay, 40, 0. So you can see here, this is the coordinate. You can refer to this coordinate. Okay, 40, 0. And you go to 44. Okay, 44. Then you go to 34. Okay, you go to 34. Click here. And go to 29. Okay, 29. So click here, 29. Okay, and then you go here, 09. Click. Right, and then you right click. Alright. Then you have another segment here, the upper layer soil. Okay, so you can start from here, from 09 to 014. Okay, 014, and to 1014. Okay, 1014 here, and you click 29. Right, done. Right click. Okay, now you have the slope. Okay, 2 layers of soil. Okay, then the gradient is 45 degree. Okay, so next, what you have to do, you have to to assign the material for each layer. So this is the properties. Okay, this is the properties for each layer. Alright, so we have to assign the material. Okay, so you can go to the soil, and then you click show material. Okay, and then you create new soil. Okay, you create new soil, and we name the first layer. This is upper layer. Upper layer. Okay, we use the more color model. Also, this is the simple model. This is first trial. Okay, we use more color model, and we use drain. Okay, we use drain. Okay, it's up to you actually. Either you want to use drain or undrain A, undrain B, undrain C, or non-porous. Okay, but in this case, I'm trying to use drain because I assume that I try to model the long-term stability of the slope, right? And you can change also the color. Okay, it's up to you. Okay, yeah, I try to choose this color. Okay. Okay. Okay, and then the unit weight is 17, right? Okay, the unit weight is 17. And then let's say this is 18. Okay, and then we go to the parameters. Okay, the Young modulus is 15 megapascal, so 15,000. Okay, the Poisson ratio is 0.25. Okay. And the cohesion, okay, the cohesion is 4 kilonewton per square meter, and the friction angle is 20. Okay, 20, and dilation angle is 0. Okay, and then you just click OK. Alright, so now we already create the upper layer properties, and we create another layer, the lower layer. Okay, we name as lower layer. Okay, use the more column, drain, and then also you can change the color. Okay, I will change to the blue color, the purple color. Right. Okay, and then the unit weight. Okay, of unsaturated unit weight is 18, and the saturated, let's say 19. All right. Okay, and then we go to the parameters. Okay, insert the Young modulus parameters. Okay, for example, we try to use 25 megapascal. Okay, then the Poisson ratio is 0.23, and cohesion is 8 kilonewton per square meter, and then the friction angle is 25 degree, and dilation angle is 0. Right? Okay, so all right, just click OK. So now we have a lower layer and the upper layer. Okay, now if you want to assign the material here, you just click, drag to this lower layer, right? Drag here, and the upper layer you just drag and put it here. Okay, and then done. So if you go to structure, okay, you see, okay, this is the color change. Okay, so means that the soil model know the properties or the behavior of soil. Okay, so if you see the star here, okay, means that you have to save the file. Okay, save the file. Right. Next, what you have to do. Okay, for the first model, I will draw without the groundwater table. Okay, so next you go to mesh. Okay, we go to mesh, and then we have to generate the mesh. Okay, you can use either medium, coarse, fine, or very fine, but I think medium should be okay. Okay, you just click medium. Okay, and then okay, you want to view your mesh. Okay, just click view mesh. Alright, so this is actually the mesh, okay, for the soil slope, right? Okay, so you just close, and then okay, star appear again, so you have to save it, and then you go to flow condition. So in this case, this is the model without the groundwater table, so I just skip this step. So okay, we go to the next step. We go to the stage construction, right? So if you go to the initial phase, okay, you can right click or double click the initial phase, and okay, for the calculation type you have to use the gravity loading because the slope is not the non-horizontal layers, so we use the gravity loading. So if you see here, okay, if you choose the K knot procedure, it is suitable for the horizontal layers. Okay, but for the slope actually there is no horizontal layers. Okay, okay, and then click OK. But if you see here, if you go to the initial phase, you see that our model is inactive, so you have to activate our model. So you just click here and click activate. Okay, you see. Okay, so here our lower layer is already activated. Okay, now we move to upper layer. We just click here and then right click, and you have to activate the soil layer. Now it's already activated for the both layer. Okay, now we have to add. Okay, we have to add layer. Okay, we name it as Okay, just double click and we name as the deformation, because you want to see the deformation. Okay, okay, start from face, initial face. Okay, you just use the plastic calculation. Okay, okay, and then you just click OK. Right, and another step, you have to check the stability. Right, you have to check the stability or the factor of safety. Okay, so make sure that you click to the initial phase. Okay, when you click the initial phase, then you add the phase, so it's become like this. So we double click this and we name as factor of safety. Right, start from the initial phase, and then the calculation type, you have to use the safety. Okay, you have to use the safety because you want to calculate the factor of safety of the slope. So you click the safety, okay, and then you just click OK. Right, now, okay, we save first and then we calculate. Okay, we calculate the model. Okay, just ignore this because we don't need to select the node, okay, or stress point. We don't need to sketch the graph, okay, for each node. So you just ignore feedback and calculate. Okay, okay, you just wait maybe 1 or 2 minutes, or maybe less than 1 minute. Okay, very fast. Okay, okay, actually it is depending on the how fast your processor. If you use Core i7 or Core i9, so I think okay, it's more faster. Okay, now this is already complete. Okay, the calculation is already complete. Now we want to view the result. Okay, you just click here. Okay, view the result. Okay, so we see what happened. All right. All right. So if you see here, this is the deform mesh. So if you see here, there is the movement here. Okay, if you see here, this is the movement. And if you want to see more detail, you go to total displacement. Just click here. So there is a slip circle here. Okay, so this is the slip circle, right? Okay, for the FS phase. So if you see deformation phase, so it's become like this. Okay, actually, if you want to report the deformation, so you can use the deformation in the deformation phase, not in the safety calculation, because the safety calculation, okay, show you very big displacement, right? So it's actually, this is incorrect. Okay, so you cannot report the displacement in safety analysis. So that's why we create the deformation analysis and the plastic analysis to predict the settlement. Okay, to predict the deformation of the soil, right? Because you cannot report this displacement in safety analysis, right? So if you see here, this is the slip circle. Okay, so this is the possibility of the slip circle, right? So if you see here, okay, so how to determine the factor of safety? Okay, how to determine the factor of safety? So you can click the curve manager. Okay, you click the curve manager and you create new, and then Okay, for the x-axis you just use default project step, and for the y-axis you use the multiplier. Okay, you choose the MSF. Okay, MSF represent the factor of safety, so you just click okay. Now you see, okay, this is the factor of safety. Okay, the value of the factor of safety. So if you see here, the value is approximately 1.35, right? But if you are not sure the exact value, you can click table. Okay, so in this table, okay, you can see the last reading of MSF. So it show you the value of the factor of safety. So actually this is the factor of safety, 1.351. 1.351. Alright. Okay, so you can print screen. Okay, you can use the snipping tool. Okay, to copy the result. Okay, and just close, and then close here, because you know that the factor of safety is 1.351. Okay, do you want to save it? If you want to save, you just click yes. If no, you just click no. Right. Alright, so actually okay, we have to view the result. Okay, for the presentation only. Okay, for the presentation, I think, because I think in Plexis the presentation of the result is not quite good if we compare with the GeoStudio. Okay, because it's in the GeoStudio it will display the factor safety in the diagram. Okay, okay, but we have to do manually, so we can plot manually. Okay, okay, you can plot the factor safety. You just click add label annotation, just click here, and you can put anywhere here. Just double click and just put fs equal to fs equal to 1.351. right? Okay, for project, and then click okay. Right, so this is fs equal to 1.351. okay, so you can print screen, or you can copy the value, okay, the diagram, and put it in your report. Okay, alright, so actually this is the result. Okay, this is the result. Okay, and then okay, this is the factor safety from the table. Okay, alright, so I think that's all. I already show you how to create, how to model, okay, how to model the slope, the soil slope in Plexis 2D, and how to analyze, how to get the factor safety. Alright, so that's all. Okay, thank you very much, okay, for your attention. See you again. Bye bye.
Baru kali loh sini. Apa ini? Hitam ini. Karena. Kati muter-muter. Mela-mela. Habis pinelpon aku aja. rampas HP. Sudah menemukan lokasi untuk para lereng. Teman-teman kami juga sudah menunggu di sana. Kami akan menyusul mereka ke sana karena mereka sudah mensurvei duluan ya. Bisa dilihat inilah perjalanan kami untuk menuju lokasi. Balik kita ke sampai sana, dari tak tangkap orang tuh.
Yang pasti bikin helm.
Tangkap. Ramen ada apa bang? Ditangkap tadi ada anak kuliah ada. Baju kayak abang inilah ada.
Mana bang?
Dari sini aja. Apa?
Terus.
Ini lah, berhenti. Wih. Kenyang kali ya makan misal. Enggak. Kan kau bisa nyelamati aku.
Berubun.
Ya, kiri.